This is This Week in Science and Education, Episode 33, Ottawa Regional Science Fair. This Week in Science and Education is brought to you by Sheridan Institute of Technology and Advanced Learning. At Sheridan, students shine brighter. Visit SheridanShineBrighter.com. This is This Week in Science and Education, a show that talks about all things science related and how to take that information and apply it into today's classroom. On this show, we are, where, Colin?
It's the Ottawa Regional Science Fair, yeah?
We're at the Ottawa Regional Science Fair. We'll talk about that and more coming up next on This Week in Science and Education. Hey everyone, it's time for This Week in Science and Education. This is your host, Kevin Cougler. Joining me as always, my friend Colin Jagoe.
We're having in person this week.
We're at the Ottawa Regional Science Fair here at Carleton University. It should be an interesting show. We've got students from all across the region talking about and displaying their different science projects. Colin, what can we expect to see as we walk around the show today?
Well, just guessing here, there's a couple of hundred projects here, maybe 300 or 400 projects, and I think this is it's a 7 to 12 science fair, so there's kids from grade 7 up to grade 12. You're going to have projects in all different categories: life sciences, physical sciences, environmental projects. And just at a quick glance, I can sort of see a few of those represented already. There's both French and English here. We'll probably stick with the English ones, just given that we're going to work to our strengths here. But it's always interesting. Whenever I go to a science fair, you always get sort of the standard science fair project, growing plants under different lights and that sort of thing, which are really great for kids learning about the scientific process. There's always a few that interest you, that you go, I never thought of that. Wish I thought of that. So hopefully we find some of those here today.
And we were at lunch today and we found some of those topics that looked rather interesting. So we're going to get to those next. And why don't we go hit some shows?
Absolutely.
Okay.
Hi, this is Tanya. Tanya's going to talk to us about her project.
Alright, so the purpose of my project was to investigate the process of esterification and see if it could be applied in chemotherapy. And I thought of this idea because one of my mom's close friends was unfortunately diagnosed with cancer, and she had to go through the process of chemotherapy and struggle through it. And she also told me about how she was constantly nauseous and vomiting and not feeling well in general. And she also complained about the scent of the drugs that were used because they don't smell very good.
Right.
So this led me to think if it was possible to create a different scent, or perhaps reduce the scent of the drugs that are given, so that it would make the patient feel less nauseous and make them perhaps more willing to take the drugs.
Right.
So what I did was I looked into scents and I found out about esters. And I found that esters are made from a combination of different alcohols and carboxylic acids. And supposedly, if you combine different alcohols and carboxylic acids, you're going to end up with esters that give off different scents. Now this led me to conduct my lab, which includes combining different carboxylic acids and different alcohols to create different esters. And if I could identify different scents, that means that different scents can be created.
Right.
So I was able to identify the scent of orange, wintergreen, apple, apricot, and pineapple, and so on.
Can I ask you how you identified them?
Yeah, definitely. Well, I did more research beforehand, and I was able to tell that this alcohol with this carboxylic acid is able to create the scent. It should produce the scent.
Okay.
And then, unfortunately, the concentration of the solution I created was a bit high, so the scent produced was really strong.
Okay.
So it was a bit harder to identify than I would have liked, but it was still identifiable.
But you still got it. Okay.
Yeah. Now, after this, it led me to wonder why certain scents can make me feel more relaxed, like lavender or candles, why it can make me feel relaxed and not as stressed, and why scents like perfumes makes me feel happy and good and just ready.
Right, sure.
Yeah. And I found out about aromatherapy. And aromatherapy is actually a rather new type of science that involves using scents to help cope with depression or anxiety or other mental issues, and sometimes even physical issues like migraines.
Right.
So I wanted to see if aromatherapy has ever been used in chemotherapy, and if anyone has ever linked the two. And I wasn't able to find many studies, which shows that not very many people have thought of combining the two.
Okay. Well, that's interesting.
So the studies I could find were one that involved a Yale professor whose name's Dr. Gary Schwartz. And what he did was he exposed cancer patients different scents, and he found that the scent of spiced apple could actually reduce lower blood pressure and systolic blood pressure and even diastolic blood pressure, which is very impressive. And another research conducted at the Memorial Sloan Kettering Cancer Center showed that the patients who were exposed to heliotrope, which is a sweet vanilla-like scent, who were exposed to this scent and went under MRIs, they felt 63% less anxiety levels than those normal patients going under MRIs, and that's a big reduction in anxiety.
That's interesting. So you've got a proof of concept in that you can create a bunch of these different esters. You've also got a bit of preliminary research that says that there may be some clinical benefits to people, to patients when they're doing it. What would be a next step for you if you could if you could move it to the next step?
Well, since my resources were limited, but if I could, I would definitely try and create some of the therapeutic scents, such as lavender, which can relax a patient, or peppermint and lemon, which can in fact reduce nausea. So if I could create these scents, then I would definitely bring them to cancer patients and have them tell me how they reacted to these scents and how they felt, which scent they liked the most, and essentially do a survey.
So take it to the next step and try and implement it. Well, you know what? You're young. Very good. Thank you very much.
Thank you.
All right, hi. We're here with Robin. This is Robin. And Robin's going to tell us a little bit about her project on magnetic fields in the sun.
Yep. So basically, I wanted to figure out if there was a relation between the magnetic field and its fluctuations and how it affected life on Earth.
So the sun's magnetic field and how it affects the Earth's magnetic field. Okay.
So I went to the sun on that note.
Okay.
And how the sun affects our magnetic field is the sun has these sunspots or solar flares caused by these opposite polarities in its outer area. So basically, this emits these electrical, like these surges of electric, these energetic forces. So that is what causes coronal mass ejections. Now these CMEs, they create northern lights, so we see those, and so basically I shrunk this down to a way that I could collect variables and data for this project.
All right, and what were your variables and data then?
So I used ants as a social creature to reflect this interaction. And so what I had to do was I took this magnet, because it's a very strong magnet, and I built this Gauss meter. So basically a Gauss meter, what it does is it measures the magnetic flux of a magnet. So attached to a voltmeter, you see that when you have a north pole, the magnetic flux decreases, and when you have a south pole, it increases. So I represent that by a graph. And then when I had the test done, the ants with the magnet, they actually formed on top of the surface at some points, which could reflect, because they were trying to adapt to a polar reversal, which is what that was, because when I calculated the vectors of this, its output was south. So they were trying to adapt to a south pole being on the surface.
Interesting.
So they were.
And so the ants actually came out of their tunnels and congregated on the top, and in your control they didn't. Is there evidence, and I don't know this, that ants respond to magnetic fields in that way? Did you do any research?
A lot of organisms do respond to magnetic fields. The same way geese migrate and butterflies migrate. Every organism basically has an inner compass that reacts to these fluxes.
I know some of the birds that do, and I've never heard it in ants before. That's really interesting.
So that was my conclusion, that these magnetic fluxes will have an effect on organisms on Earth. And as the sunspot, the cycle continues, we have solar max and mins. Our solar maxes occur every 11 years. Our last one was in 2001. If you add 11 to that, you get 2012, which is a new number.
What's the word? The strength of the magnetic field. Like the Earth's magnetic field is pretty weak compared to this one in relation to the ants. Did you do any sort of thinking about the strength of that one compared to the Earth?
So basically, this was like I said, it was shrunk down to size. It's not proportional to the Earth. So so I was just analyzing if there's ever a polar shift, what would happen?
What would happen?
And this magnet actually had a field vector of 23.5 centimeters.
Okay.
So I tested that using another magnet, and when the polarity shifted on it.
Okay.
So I was able to prove that.
Interesting. Interesting. Okay, so your conclusion is that then ants are affected by magnetic fields in this way, and then by proxy, you're saying the organisms in general.
Yeah.
Very interesting.
Thank you.
Okay. Cool. Nicely done. Have you had all your judging yet?
Not all of it.
Not all of it yet? Well, good luck with the rest.
Thank you.
Okay, thanks, Ron.
Okay, so we're here with Ian and Jack, and they've got a neat idea about power conservation and prioritizing power on a, well, really in the home. Guys, this is Ian and this is Jack. They're from Cedarview Middle School, is that right?
Yep.
Here in Ottawa. So they're going to tell us a little bit about their project. Go ahead, guys.
So what we built is a power management system that efficiently manages electrical power from a low or inconsistent power supply.
We got this idea mainly from my dad because when my power goes out in my house, we have to run the house on the generator. So my dad is constantly running around flipping switches in our circuit panel. And basically we built this machine to help him out and do all of that stuff automatically.
So like imagine if your house is running on a generator because the power's gone out. It would, and your fridge is running, it would, and maybe your sump pump needs to run, it would detect the sump pump starting up and shut down the fridge so that the sump pump would have enough power to run its full cycle. Then when the sump pump's done, it would turn the fridge back on.
It's kind of like the smart house concept, basically.
Yeah.
Yes.
And not only did you guys create the circuitry here, but you also wrote the computer program that makes it happen too.
Yeah.
Yes.
We wrote the program too.
Let's just have a look at the program there. Pull it up. Okay, what language did you write it in?
We wrote it in Python, which is in version 2.7.1.
Awesome.
So this could also be used when your house is running on, for instance, wind power. This machine would detect the drop in wind speed, and it would then manage all the circuits accordingly.
Sounds great. When can we see this in a store near us, guys?
We're not quite sure about that. We are working on getting like a patent or something for this, but
okay, good for you.
But after some searching, we found something that's similar, so we're doing more research into that.
Okay. Well, that's Ian and Jack. Thanks, fellas, for your time. I appreciate it. Got a great little project there. Wonderful.
Thank you.
Good job.
I'm here with Elizabeth and Zoe, and they've got a really interesting project on EMFs. So I'm going to let them give a little explanation on what they did. So tell me what you did, girls.
So our project is studying the short-term and long-term exposure of electromagnetic radiation to algae and mold to see how it affects their growth and reproduction. And what we did was we grew mold and algae, and then we exposed it to EMF, which is the radiation that is produced by electronic devices, and we put it in the path of EMF that is emitted from an industrial amplifier, a television, a computer, and fluorescent lighting.
Now, did you have a control where you didn't have one not exposed at all? Okay.
Yeah.
Why did you pick mold and algae?
We picked mold and algae because it's been said that if human beings are exposed to EMF, it has several negative effects on their health, and this can cause things like brain tumors. But since we can't expose human beings to EMF, we decided to go with a lower form of life that would be mold and algae. That would be way easier to examine.
Okay. And so your hypothesis was what? That growth would be different? That
it would kill or like
seize growth.
Okay.
And our hypothesis was incorrect, and it actually increases growth. Especially, it's very prominent among mold. You can see it rapidly growing.
Interesting.
And we thought that this would be really important to incorporate in real life, because if there is mold growing in schools, and if there's so much EMF,
air vents,
and if there's so much EMF that is produced, this can cause mold to grow even more. And if people have allergies, they can get really sick.
Interesting. Did you do any measurements of the field strength? Did you get any EMF meters and measure the field strength?
Well, that was like our initial project, but they're kind of very expensive, like $300 to $400.
Sure.
So a bit above the school budget.
Yeah.
Where's your teacher? He wouldn't buy it for you?
No, he was trying to get one for us.
And we were actually thinking about building one.
Wow.
Yeah.
Okay. And then that sort of became a bit of an issue as well?
Yeah. And then it was involved into this.
Okay.
Yeah.
All right. Any ideas what you might want to do? Like you found something that you didn't expect to find. Anything, further thoughts that you might want to do more investigations on?
We were thinking that perhaps if we did a next project, maybe next year, we would be thinking about how we can measure the levels of EMF and find out which electronic devices emit the most EMF, and do some more research. And this way we could say, like for example, if a television produces more EMF than a computer, see if it's really true and see if it affects the algae and mold's growth again.
Very cool. Very cool. Very important research. Right? And nicely done. Thank you very much for your time.
Thank you.
Hi everybody, so we're here with Franny. Franny is a grade 8 student here at Turnbull School in Ottawa, and Franny has a project on how to keep seniors safe. And Franny, we actually have a volunteer from the audience here who is going to test out your new stairs.
Excellent.
But before we bring him in, maybe you can tell us a little bit about how you keep the seniors safe.
Well, this project is a continuation of what I did last year, where I changed 3 things about stairs. The size of the run, which is where you put your foot, and I made it longer to accommodate the fact that the average human foot size is increasing. I changed the size of the rise. I made it smaller, how tall the stairs is. I made it smaller because we have a very quickly aging population. And as you get older, your range of joint motion decreases. And I changed the size of the nosing, which is the little overhang on steps. I made it smaller so that it would be less of a tripping hazard. So, with that, I submitted my results to the government, and my changes are being incorporated into the 2011 building code. So,
good for you, Franny. Congratulations. It's wonderful.
Thank you. And off of that, I decided to continue with my project to try to incorporate the railings into the project. So I tested the lower and upper and middle range of the current building codes for stairs to try to see what would be the best. I went to an elder care facility, St. Pat's, and I tested lots of younger kids in my school and adults and neighbors and friends to try to see where they felt most comfortable within that range. And consistently, everyone wanted it to be low or lower than it is right now, which goes to show that not a lot, the building code isn't updated very frequently, but also there isn't a lot of human testing like there is on other aspects of it. So I felt that there was kind of a gap in the building code there where it needed to be considered, so I thought that I should do some work on it.
Okay, so speaking of the steps then, we have a volunteer from the audience. Sir, can you come in here for a moment, please? So could you tell us, what's your name?
My name's Ron.
Hi Ron, thank you very much for being our volunteer here today. We're going to have him go up and down the stairs, and Franny, you can tell us what we're looking for here.
Okay, sure. So right now these stairs are set at the current building code regulations. These meet building code, and both of these railings meet building code at the moment. And if you walk up and down using the lower railing the first time and the higher railing the second time, and tell me how you feel in either direction.
Do you need a hand, sir, or are you okay?
Upper rail going in?
Sure.
Okay.
And also you can try doing the opposite, going up with the upper railing and going down.
Yeah. And down. Okay. Alright, okay.
How did you feel?
This is the good one.
Pardon?
This one's better for me because of my height.
Okay.
Yeah, so I think that's what we're...
Sure.
Yeah.
Okay. Thank you, Ron, for participating. We appreciate that.
Absolutely.
This is wonderful, Franny. Thank you very much for telling us a little bit about your project.
Thank you very much.
All right, we're here with Itzel. You're from Ottawa, Itzel? Yes, nice to meet you. And she's going to tell us about her project around recycling.
So what I did was I wanted to find out if recycling bins should be placed near or far from garbage cans. So during class, which is 40 minutes long, I put the recycling bin right next to the garbage can, and I observed what recyclable items people threw out in the garbage can. I did that 5 times, so 5 trials. Then I moved the recycling bin 6 meters away from the garbage can. And again, I did 5 trials, each 40 minutes long, and I recorded my observations. And I found that there was a 5% difference, so 5% more recyclable items ended up in the garbage when the recycling bin was away from it. So it is more effective if recycling bins are closer to garbage cans.
Closer to the garbage can. Did you notice people making a decision when the kids walked up to the garbage can and they saw the recycling bin far away? Did they sort of did you pay attention to that, or were you just strictly noticing the materials going in?
I noticed that sometimes.
Yeah.
But sometimes they just walked right by the recycling bin.
Really?
With a recyclable item, and they threw it in the
Had headed to the garbage, right? So yeah, so it made people think not so much. Then is what you're saying. It's very interesting. What lessons do you have to take away from this then? What do you think we should do in schools?
You should have the recycling bins right next to the garbage cans in order to recycle more.
Even when they were right beside it, did you notice things like not being recycled? What would you do to help that? It's a bigger question, I know.
Well, maybe if the recycling bin is maybe farther away from the exit, the garbage can is right next to the exit.
Right.
And the recycling bin is
so that was actually another...
The last thing they see is the garbage
Right.
can.
So that was actually maybe another variable, the location of
Which one?
nearest the door as they're on their way out, right? Interesting. That's something to think about for your next one. And do another trial and swap them. Put the recycle can by the door and the garbage can on the other side of the room. Interesting. That's very cool. Thank you for your time.
Thank you.
Okay, so we're here talking with Glenn McDonald. Glenn is part of the people here that are celebrating the 50th anniversary. You're actually on the committee, are you, Glenn?
That's correct. I'm a representative from Algonquin College, and we sit on the committee. We act as more liaison just to make sure that the college's interests are also represented at the fair. But I sit on the committee to celebrate the 50th anniversary of the Ottawa Regional Science Fair as well. So we put in a fair amount of effort to contact past winners from the last 50 years and to bring them back, ask them for memorabilia, T-shirts. As you can see, we've got some news clippings. We actually have one of the projects from 1974 featured here as well.
So Glenn, how difficult was it to find the past people to invite them again?
Well, it's actually kind of interesting because we took two different approaches. My counterpart, Steve, went through the phone book. We had lists of people, honest to goodness, we had lists of past winners. We had their names and the high school that they graduated from or that they competed in.
Yes.
And so his approach was to go through Canada 411 and the phone book and do it sort of the old style.
Nice.
What I did was I tried to track down some of the more recent alumni from the show and, from the fair. And I went on Facebook.
I was just going to ask you if you had Facebook.
And it was kind of interesting because I was able to contact about 60 people in about 3 hours, where Steve was probably days and days and days going through the phone book. But it's interesting how many people he was able to track down. I mean, we actually had some folks that participated in the first science fair show up, and he did it by the old-fashioned telephone book.
Wow, that's great.
Yeah. So we had about six representatives from past year's competitions here, and it was interesting. We had lunch with them, and just to hear their stories.
Was there any stories on sort of the long-term impact of being successful in a science fair, or did you talk about that?
We did, and it's interesting because not only amongst those 6 people, but the other people that we've contacted, and it's interesting to see that a lot of them did go on into science. So they studied maybe science in some area at university, or they're off getting a job. Now, can I tell you a percentage?
No. Of course.
But it's interesting to see the impact that the fair did have on some people. As a matter of fact, one of the past entries from I believe 1997, the competitors actually got married.
Oh, really?
Yeah, and they're actually here today.
Not that year, but in years following.
That's correct.
Okay,
yeah.
Did they meet here? Or were they?
No, well, they went to school together.
They
were on the same team. But just to, it's interesting just to hear some of the stories. So, did it have an impact on them? I hope so. It looks like it.
And your children, apparently. Yeah,
That's right. That's right.
See if their kids are here in a couple of years.
Yeah.
Super, Glenn. Thanks very much for coming on the show today. Appreciate it.
Have a good day.
We're here with another project. Maybe you guys can introduce yourselves this time and tell us a little bit about what you got here.
Yes. I'm Heidi Lead.
And I'm Kim Song Chen, and we're from Colonel By Secondary School in Gloucester. And our project focused on the presence of bisphenol A in receipts from the Ottawa area. We looked at receipts from large chain grocery and retail stores in Ottawa, and we collected 14 receipts from 2011 and 3 receipts from 2005. These receipts had their chemical compounds extracted and analyzed with gas chromatography and mass spectrometry.
Right.
And so we discovered that 21% of the receipts from 2011 and all of the receipts from 2005 had bisphenol A.
Okay.
Bisphenol A is widely used in the manufacturers of products that you use in your daily lives. For example, your polycarbonate water bottles, food and drink can linings, and most importantly, thermal paper. BPA has been a growing concern among the general public, as many studies have shown that it has negative effects on human health. Some studies have shown that because of the chemical composition of BPA, it mimics estrogen, which can increase the risk of prostate cancer in males and breast cancer in females. And other than this, high levels of BPA are associated with heart disease, diabetes, infertility, and etc.
And we know that some manufacturers are actually making the change to BPA-free thermal paper, as only 21% of the receipts from 2011 had bisphenol A.
Okay, so 21% from 2011 had them. You know what? I'm gonna admit my ignorance here. I had no idea that BPA was used in paper. And you told me a minute ago what it was, why it was in there. Can you sort of give me the why is that term? What part of the process is BPA used in?
Sure. Bisphenol A is used in thermal paper directly on the paper. The difference between thermal paper and standard paper is instead of printing the ink directly onto the paper, the ink and the dye in the developer is already on the paper. So when you apply heat to the receipt paper, the dye interacts with the developer, which is usually BPA, and creates the words that you can see.
Oh, so it brings the words out then, the heat brings the words out instead of printing them on.
Yes.
The dye is already on the paper, and BPA is part of that dye. Very cool, very cool. Has there been any studies on sort of the transfer from paper to people?
Yes. Actually, a study by the official health authority of the canton of Zurich in Switzerland found that simply by touching bisphenol A, simply by touching the receipt, bisphenol A can transfer to the skin to such a depth that it can't be washed off.
Wow.
And our results found that 21 receipts collected from 2011 had bisphenol A, while 79% were BPA negative. But in our sample group collected from 2005, 100% had BPA.
Right.
And what was interesting was we collected 2 Canadian tie receipts, one from 2005 and one from 2011. The 2005 receipt had BPA, while the 2011 did not, but instead it was replaced by another phenolic compound, which is phenylmethoxynephthalene.
Okay.
So we assume that this was used as a substitute.
Right, right. You didn't phone Canadian Tire or any of the paper manufacturers to see if they're actively changing those kinds of things?
No.
It'd be interesting.
Yeah.
Very interesting. You know what? I just learned something, and I like it when I learn things. Very cool, guys. Thank you very much for your time.
Thank you.
All right, we got another project. Maybe you can introduce yourself and give us a 2-minute sort of what this is all about.
For sure. My name's Satya Bhaskar. I go to Nepean High.
Okay.
So about every year, 1,400 Canadians have to undergo intense therapy in order to improve their spine.
Okay.
There's less than a 1% complete recovery. My project looks at regeneration over therapeutical practices.
Okay.
And therapeutical practices is what's being done currently right now.
Right.
So what I did is I created 2 different types of tubes, dip coating tubes and microsphere tubes.
Okay.
The first was a dip coating tube, and I fabricated them. I characterized the biomechanical properties, and I did a pilot clinical rat study on it. So from this, I learned 2 different lessons. The first was, since it was fabricated with various layers, it had a low Young's modulus, or it was very weak, and also it dissolved in a time frame of 3 weeks. It's supposed to last approximately 6 weeks.
Okay.
So
when you say you had a clinical study on the rat model, what exactly did you do?
Well, it wasn't actually me who did the clinical study.
Okay.
It was done by researchers at the OHRI at Eve Sai's lab, and she actually took the dip-coated tubes and placed them in adult female Sprague Dolly rats.
Okay.
And the rat had managed to move its legs 2 to 3 times, which is, I think, ranked in a 10 or 11 on the Basal scale. And what the scale is basically, it's a scale for paralyzed rats, which is ranked 21 being your full mobility.
Okay.
So, I wanted to overcome these 2 problems that the previous tube was having. So I constructed a different tube through a whole process and did SCM scans on it. I found out that since the dip coating tube is made up of various layers, it undergoes it's almost like a spaghetti if you place tension on a spaghetti, it cracks.
Right.
Whereas if you have like a ping pong ball, if you have a ping pong ball and you place tension on it, it dissipates over the whole tube.
Right. Okay.
So that's why the ping pong ball is far more stronger than the spaghetti.
Oh, okay.
And then that can be noted in the comparison between them. So that's just a graph.
Right, sure.
And then, so I placed the dip coating tube inside the rat, but I wanted to do the same for the second tube, the microsphere tube.
Right.
So before I can do that, I first needed a tracking reagent. So I added iron particles and conducted an MRI scan on it. Okay. And I determined that a 1 to 0% iron particle range is perfect to get a clear image.
Okay. So did you actually get around to putting the second tube then into the rat and testing
no,
that?
that's my next stage.
That's next step.
Yeah.
Okay. All right.
Yeah.
So with this obviously, so you said you didn't do the clinical research or the clinical part of doing the rat. So when they did this, could you maybe just tell me exactly what they did?
Sure. They just. I don't know the exact details because it wasn't my lab that did it.
Sure.
It was E-size. They made an acute cut. Yeah. Took a piece of the spine out, and then I think they used this tube here as
to glue it
as a bridge
together,
almost, and that allows information to pass.
Right.
Yeah.
So it's an actual clinical cut.
Yeah.
And then they put it back together using this technique.
Yeah.
And so sort of monitoring it.
Yeah.
For the mobility and whatnot on that scale that you talked about. Excellent. What's next for you?
I'm actually looking at taking these tubes and placing them in the rat model, the MST, the new different
you want to do that next?
Yeah. That's my next stage.
All right. Thank you very much for your time.
Thank you.
Good luck. We're with VanGoorl, who's co-chair of the organizing committee for the Ottawa Regional Science Fair. It's a great event. How many kids do we have here today?
We have 296 participants today.
Okay. And that represents just about everybody in the Ottawa region, the various school boards?
Pretty much. We do have 33 schools with us today. Okay. And students are sort of from all those schools. They come from all parts of the Ottawa region, the National Capital Region.
Right. And it's 7 to 12 this fair, is it?
Grades 7 to 12.
Okay. How many participants do you send to Canada-wide at the end of the day?
11. So we send 11 projects to Canada-wide, which is in the Toronto area this year.
Okay. Excellent. What's your impression of sort of the fair culture in Ottawa? I know, it's, like you said, it's different everywhere, and I've been part of them in other places. What's the feeling of science fairs around here? Because it's sometimes hit and miss in other places.
Well, there's certainly an excitement here, and that's really wonderful to be part of, because I think students really need a place, a forum where they can come and share their passion for their work, for their interest, as well as for science in general. And I think this is a good place for it. They all come here together and they participate, they get to see one another's presentations, projects, and also speak with judges, and some of these people are from private corporations, industry, government, universities, and other institutions, and they get to talk about what it looks like to be a scientist and a professional in the field, and I think it's a great opportunity for these students to discuss those topics.
Yeah, I was going to ask you about the judges. Is it mostly professionals and like profs and people working in science-related field or industry that you have here for judges?
Yeah, that's about pretty much sums it up.
How many judges come through here?
Ooh, I don't know the exact numbers, but it's about 130 to 140.
130. So they come around, and because you're almost finished judging now. It's 3 o'clock here now, and the judging is pretty much done, is it not?
Up until 4, yeah.
Up until 4. So talk to me about the logistics of the day. How do you get 300 kids, 120 judges, all judged? How many times does each project see a judge? 2, 3, 4?
Yeah, it depends, right? Divisional judging happens maybe about 3 or 4 judges, and then there are special awards. It depends how many students or how many projects have been nominated for a judge, for an award. Sorry.
Yeah.
And they self-nominate online, and then judges will be able to look through the list and see if others will be added. And so it depends. Depending on that number, you can be judged 4 or 15 times.
Right. So when the judging is done now, they all come together and there's a mad flurry of paperwork and discussion, and it all works itself out by the time the award ceremony comes around.
Fate is the word that I would use. Fate.
Having been involved in the background of some science fairs, I know exactly what's going on right now in the judging areas.
Total chaos.
It's absolute chaos, but it's so much fun. Because everybody says, did you see this one? Did you see this one? And they go through, and this person had a great question. The methodology was they missed a few bits and pieces, but it was a really interesting question. It's so much fun from a judge's point of view to get to dig into the actual process of science.
They really dig in.
Which is so much fun.
And you know what? It brings up discussion that you would have never had around the table upstairs, and they start posing themselves questions about what they do as scientists, and it's an amazing opportunity for everybody to be part of that discussion together.
Yeah, I know. And it's, as I was walking around, I was struck. I mean, first of all, the wide range of projects, like any science fair, which is really cool. Some things that are beyond my comprehension in terms of the understanding of it, right? But then other things are very simple, interesting questions that you go, geez, I never thought of that. Right, but it's a good formulated science question, right? Just simple things, and just looking at that range. Like I like getting kids into it. Speaking of kids, one of the last questions I have: do you guys do support for schools during the year? Do you offer resources? Do you offer workshops? Like, is there anything before this that you guys do with the schools and teachers and students?
As it stands, we don't. We do have an outreach committee that was struck this year, actually, because it's our 50th anniversary, I should point out.
Yes, that is true.
And so we have a little booth set up with all sorts of memorabilia. We had a gentleman that showed fiber optics. It was cutting edge at the time, and so we have his display there. And we thought that wasn't going to go anywhere 50 years ago. Well, little did we know. At any rate, this outreach committee is getting involved with schools to see how they can better integrate with the fair and stepping into the schools to talk about what's done at these fairs and how to work towards them and to prepare projects in advance, fit that into the curriculum. However, we're not so much offering workshops and things of that nature. We might do that in future. It's something to look at. It depends on the volunteers we have in the committee.
Yeah, and I know just from across the country, just science fairs, it's an interesting animal because the Youth Science Canada oversees the whole thing, and then the regional fairs all have their own little thing. But then the schools and the school boards are sort of on the periphery of what it's an interesting dynamic, and it always amazes me that the excitement is still there. Whenever the kids show up with their projects, right, and you talk to them, and the depth of, and this is one thing that I totally noticed, you probably see the same thing, the depth of understanding in their particular area is always amazing, right?
Outstanding.
You know, we always complain in education, I do, as a teacher, just curriculum being, mile wide and an inch deep, right? But when a kid does a science project on whatever particular thing, like a BPA over there, talk to the kids that did a little BPA analysis. They have an understanding now of BPA that I don't have and most people don't have, right? Which is just really cool. And when you talk to them and you explain that, and I said to them, I just learned something talking to you today. Right? I didn't know that.
It's fantastic.
It's awesome.
You work on those skills to be able to comprehend, and you go up to higher order thinking skills by analyzing, synthesizing, evaluating, creating, and they take ownership of this topic, and then they get to communicate that with everybody else. And those are skills that aren't very easy. And this is an opportunity for them to hone those, and it's a great environment, a safe one, an open one where we can make mistakes. It's great.
Yeah, it's a beautiful thing to see. Right. If we want to find more information out about the Ottawa Science Fair, where do we find it?
Well, the easiest place to find information is on our website, www.orsf.ca, the Ottawa Regional Science Fair. And we have contact information there. We have information on past fairs and how the whole thing is run.
And this year's winners will be up there as soon as they're announced.
You know it.
Awesome. Thanks for your time, John.
Thanks a lot.
Appreciate it.
Appreciate it.
All right, take care.
Okay, so I'm here with Saqib and Mohammed. They're grade 8 students here in Ottawa, and they have an interesting project on how to capture the energy caused by earthquakes. Who would like to talk a little bit about that?
Okay, so starting with what happened last year in Haiti, we know that earthquakes are very destructive and dangerous things, so we wanted to find a way to harness them to generate electricity for the victims of the earthquakes instead of them just being seen as terrible.
So we decided to create a device that could actually do that and generate, and then what we could do is that we could harness the vibrations from the aftershocks, and then we could provide power to the victims of the earthquake.
And so this is the device here that we're looking at that will capture that. Maybe Saqib, you could walk us through how this device would work?
Alright, sure. Over here there's a pendulum, and basically what happens is when the vibrations come, it basically swings the pendulum and it'll go up and then it'll come back down because of gravity and momentum. And this process will continue for the duration of the earthquake. So basically,
make sure you speak into that.
Here's a generator that will produce the electricity that we're looking for.
And then next, after the generator, we have an electrical transformer. And what this device does is that it actually multiplies voltage, because we weren't making it as much voltage as we'd like, so we used the transformer to multiply it. And then later on we got a circuit which is called a bridge rectifier, and that affects the current to be put into a battery. So finally we have a battery pack.
Super. And you were mentioning before that getting the energy out of the battery pack is not really the challenge. The challenge is how to get the energy in there.
Exactly. Which we have accomplished.
Which you have. Thank you very much, Saket and Mohammed from Ottawa. Thanks, guys.
Thanks.
Okay, so we're here at a technology booth. Unfortunately, our students aren't here, but I'll read you their names. This is a project by Jordan Geist and Rachel Cardish, and joining me is my good friend Norma Bingham.
Hi, Kevin. Pretty exciting stuff going on here. This is an actual project on internet cookies, and the two individuals who set up this project have looked at what cookies are, tracking cookies on the internet, and they're actually taking a look and doing some experimentation as to tracking these cookies and how individuals who are interested in advertising and so on can actually map out your history online, so to speak, and find out where you have been and the type of sites that you've gone through. They've done it according to scientific method. They've tested things out. They've gone to several different sites focusing on different topics and so on, and they've actually done some actual quantitative data on here. This is quite exciting. I'm not sure what grade level this is. It kind of looks like it might be intermediate, so maybe grade 7, grade 8, I'm not sure. But they've really followed things through carefully. And it's interesting in that they started off with a hypothesis, and they're talking about tracking cookies and tracking geographic location. I knew about tracking cookies as far as your habits on the internet, but I wasn't really aware of the geographical aspect of it, which is kind of interesting when you're talking about digital citizenship and your digital footprint and so on. It's quite impressive what these individuals have been able to do.
And you know, Norma, one of the things that we should all be concerned about on the internet is internet security. You know, and are these cookies playing a factor in that? Speaking of the geographics, one of the experiments that they performed was to use some type of a program to make it appear as if they were surfing the web from a US location, and they had some different results. All of a sudden the results weren't as targeted toward their browsing habits. The ads that popped up on the computer screen were very random in nature. So this is the folder that students have come up with. Are you being tracked on the internet? And it looks like a wonderful experiment. Kids have done a great job.
Well done, well done. This is very, very good. Nice to see.
Super. Okay, so we're here with Jacob. Jacob is a grade 8 student here in Ottawa. He's got an interesting project. Jacob, why don't you tell us a little bit about it?
Okay, so I'm doing my project on recovering waste heat. And basically what that is electricity which escapes from electronic systems in the form of heat. So, for example, how a computer will heat up. Now, I thought, well, why don't we, instead of trying to get rid of that heat, like with a fan in the computer, why don't we try and gather that heat and use it as electricity again? So I've looked it up and I found the thermoelectric effect. And now what that is basically any conductor which is exposed to a change in temperature will create a voltage. And that was found by Thomas Seebeck. Now, I used a thing called a thermocouple, and what that is, it is two different metals formed together to make a joint, which again, when heated, will create a voltage. And then, for a heat source, I used a resistor. Now, what a resistor does is it resists the flow of the electricity, hence the name resistor, and then it will give off heat in the process. I have my setup, and this is the power source, and then this is my experiment. So this is the first experiment, and this is the second experiment. Now what I do is I run my power through a resistor, which is in here, and this resistor is a half watt 50 ohm resistor, and this one is a quarter watt 100 ohm resistor. Now when I run the power through, it will create heat, and it will heat up the 6 thermocouples that are around each one. So with the first experiment, when I just ran it through, I got 0.8 millivolts just from this. And in the second experiment, I got 4 millivolts just from that. Okay? So now, can't only use the voltage, so I wanted to know how much power I could use with that voltage. So to do that, I took a bunch of other resistors and I ran the voltage I got from the thermocouples through those resistors. Now the best resistor to use for my first experiment, which I got 0.8 millivolts from, was actually a 0.9 ohm resistor, and then with that I got 0.544 microwatts from it. And for the second one, the best one, was actually a 7.1 ohm resistor with, and I got 0.811 microwatts from it. And in both cases, the efficiency of it was very, very low, and it wasn't even close to 1 at all. In conclusion, I think that well, the second experiment, so this one, was a lot better than the first experiment, and that is because in the different experiments, so in the first experiment, I had it arranged differently. So I had it arranged in a parallel arrangement, and the second one, I had it arranged in a series arrangement. So I believe that that changed the outcome of the project a lot. I do not think that this is actually a practical thing to use in real life unless it is needed for a last resource because of how non-efficient it is. And to have it very efficient, you need to make a lot of the thermocouples, and I think that instead of worrying about recovering the waste heat, we should only worrying about reducing the waste heat.
Excellent. Well done.
Thank you.
So, yeah, good job.
Okay, so now we get a chance to meet Dad. This is David, and David is Jacob's father. David, remarkable son that you have there. Tell me a little bit about how much help did you give him to do the science experiment?
The seed of the idea, of course, was Jacob's idea. He came up with the thought that maybe we could recover some heat energy from things. And I have an electrical engineering background. I knew about the thermoelectric effect, so I helped him order some stuff online and sort of showed him what to do in the basement with the blowtorch and that sort of thing. But he did a lot of the work and I did a lot of the helping.
That's awesome.
Certainly shows. Norma, any questions for proud Dad here?
No, I'm just really pleased that you've been able to support him. It just sort of plays out in our mind how important it is for parents to become involved in supporting their kids in education, and just giving him the freedom to take the idea and run with it. I'm sure your house must have had lots of things everywhere, and it's not exactly the tidiest at times. It probably had some incredible discussions and maybe even arguments around the supper table. But just thank you so much. He's done a wonderful job, and I thank you for letting us interview him, and we'll look forward to bigger and better things.
One last question for Jacob, if I may. Jacob, what's it like to be able to work with your dad on the project?
Well, it's fun.
Frustrating sometimes, I'm sure.
He didn't know that question was coming. That's a completely real answer.
It's pretty fun, and it shows me, it just opens doors about what I want to do in the future too, and if I want to do what he does.
Well said. Thanks, gentlemen. Appreciate it.
Thank you very much.
So we're here with Barbara Vanderheiden from Partners in Research and from the University of Ottawa. She's here to present an award today at the Ottawa Regional Science Fair. Barbara, tell us a little bit about that award.
The Partners in Research Award is one of these special awards for the Ottawa Regional Science Fair, and the students are eligible to apply for this award or to be considered for this award if their project has any aspect related to medicine.
Colin and I got here quite early today, and we've been walking around. We've been struck by the number of experiments that are just absolutely brilliant. Have you had a chance to walk around the floor yet?
I have. I've been spending the last hour or so walking around and looking at some of these displays, and I agree. The students are amazing. They are extremely bright. I think brighter than I ever remember being when I was that young.
I'm sure that's not true, but
no, they're bright. And the judges this morning and this afternoon, when they contacted me with who they thought the winners would be for this special award, said that they had a terrible time deciding. It was a real challenge to come up with one that might be better than the others.
So then, Barbara, you have the inside scoop. Are you announcing something here? Or,
I will be in about half an hour announcing the winners of the special award for Partners in Research.
What sort of criteria do they use to select the awards? What are they based on?
So for the special award for Partners in
Yeah.
Research, the main criteria would be related to medicine, but of course the judges are looking for how well the student can describe why they are doing this study, how they did this study, and if they can explain the data, if they have data that they have obtained. Basically, not only to understand the project itself, but how well the student can describe it.
Right. So almost related with the science fair judging itself, just the quality of the question, the quality of the research, and the analysis, and all that.
Well,
but specifically medicine. Yeah.
And our special judges are all in health research themselves, and so we brought in judges who are actually working in the field.
Good. Have they done this before? The judges you picked, or have they been?
Some of them have done this before.
It's always interesting to see a new judge come into it and go, I had no idea kids could do this.
Yes,
right?
yeah, and they are
It's a lot
young.
of fun.
Yeah, many of the judges were actually graduate students in health sciences or medicine at the University of Ottawa or Carleton University, and some of them were doing it for the first time. And I think, yes, as you say, they're the ones that were most impressed.
It's always fun.
Now, Barbara, you're a huge proponent of outreach and students getting involved in science. Partners in Research is just one of those organizations that you work with. Talk a little bit about some others that you work with.
Yeah, so I set up the Let's Talk Science program in Ottawa about 20 years ago. And it has become one of Canada's largest programs. We have about 250 graduate students from the University of Ottawa and Carleton involved, and of course this program encourages the students to go into the community and deliver science workshops or science activities in the schools. And then 5 years ago I started a program where we deliver those science activities a little further abroad. So we've been going up to the remote areas of Northern Ontario and Nunavut, and this spring we'll be going for the first time to the Northwest Territories, and that program we call Science Travels. It's sort of the traveling arm of Let's Talk Science.
Nice.
Yeah.
And if you had a message out there, Barbara, for students and how to get involved in science or to maybe inspire them to be involved, what would that message be?
Oh, do it. It's a no-brainer. It's a lot of fun. It benefits everybody. It benefits the students who are involved, and it benefits the graduate students who participate. It doesn't require a lot of effort, and it's certainly a lot of fun.
Barbara, on behalf of Colin and myself, thank you very much for taking the time to join us today.
My great pleasure. Thank you.